My name is George William, a BED student, third year taking mathematics, and my fellow.
My name is Pius Albert Manya, a third year student, physics and mathematics. Here we are going to present project work concerned with Cauchy Riemman, mostly in polar coordinates. Okay, this is Cauchy Riemman. In a complex analysis, the Cauchy Riemman equation describes the condition under which a function is differentiable and analytic. This is f of z having both function u and z. That is a u in a real part and v in an imaginary part. CR equation ensures that the derivative of the complex function is independent of the direction for which it approaches. In a real calculus, derivative are taken along one direction, that is x direction, but in a complex analysis, that is f of z, can be approached from infinity to many directions as shown in this one. Then f of z having both u and v. Then the Cauchy-Riemann equation, this is the partial of u with respect to x equals to partial of v with respect to y, and the partial of u with respect to y equals to the negative of partial of v with respect to x. Consider this one. This is an equation of f of z having u as a real part and v as an imaginary part. That is in a polar coordinate, and the f of z equals to u having both function of r and theta plus function of v having r and theta. We are going to consider an angle and the radius in a polar coordinate. So x equals to r cos theta as we know, y equals to r sin theta as we know. Then we are going to substitute the Cartesian coordinates in a polar one. Then the function will become in using a chain rule, then the partial of u will be given by this formula, and this the x, the r equals to cos theta as we differentiate the function of x with respect to r. Then the final for the case of v and the theta, then this is partial v and the theta will be given by this equation. Then substitute this Riemann equation in a Cartesian to the equation above, then we obtain this one partial u with respect to r equals to 1 over r, a partial v over partial theta. Then for the case of v theta, then this partial v and partial theta equals to r du, partial du and dr. Then we are going to look on the application.
Also, let's see the application of Cauchy-Riemann equation in polar coordinates. Cauchy-Riemann equation in polar coordinates are used in various fields such as in fluid flow around the cylinder pipe, electric field in cables, heat transfer in pipes, airflow and turbine design. This application are shown in the figure below. As you can see, we are on the above diagram, we have 4 figures, and these 4 figures we can describe them. Also, in fluid flow along the cylinder or pipe, water flowing smoothly around the cylindrical pillar with curved streamlines. Then in fluid mechanics, we can define velocity potential as phi in bracket r comma theta, stream function as phi in bracket r comma theta. This satisfies the polar Cauchy-Riemann equation, whereby partial of d phi over d r, it will be equal to 1 over r d phi over d theta, comma d phi over d theta equals to negative r d phi over d r, meaning streamlines flow and equipotential lines intersect at 90 degrees. This implies that it helps an engineer to calculate water speed around the pillars and pressure distribution. Electric field in the cables. In the figure above, we see a cross section of a cylindrical electrical cables. We have electrical potential V in bracket r comma theta is harmonic, whereby the product of nabla square and V equals to 0. Polar Cauchy-Riemann equation guarantee ER equals to negative partial V with respect to partial of R, comma, E theta will be equals to negative 1 over R partial V with respect to theta, mean that field lines split smoothly in a conductor and no sudden field distortion. In bracket prevents sparks, hence used in designing of insulation thickness and optimize cable safety. And this marks the end of our project.